Determining parallelograms using properties of diagonals of quadrilaterals. Today, we will apply the properties of diagonals in proving parallelograms. So, my name is Karen, and welcome back to Inquisitive Kids. This is exactly what we're going to be doing today. Continuing last time when we started determining parallelograms using the properties of its sides and angles, this time we're going to look at the properties of its diagonals and use that to prove parallelograms. So this is part 2 in our lesson determining parallelograms. Learning goals. Determine parallelograms using the property diagonals bisect each other and apply this theorem to solve problems. So let's do some review. From the last lesson, here are the methods of determining parallelograms. These are all of the methods that we looked at last time. So the first method was, in words, it would be described as a quadrilateral with two sets of equal opposite sides is a parallelogram. Method 2, a quadrilateral with a set of opposite sides that are parallel and equal is a parallelogram. And if we were to do this according to definition, a quadrilateral with two sets of opposite angles equal is a parallelogram, and their corresponding visuals are also shown. So today we're going to be looking at the third method of determining parallelograms. The midpoints of two wooden strips AC and BD are overlapped and fixed with nails, and then a rubber band is wrapped around the endpoints A, B, C, and D to form a quadrilateral ABCD. What is the relationship between the opposite sides of the quadrilateral ABCD? So this is our quadrilateral, and we are being asked the relationship between ABCD, AB and CD, and BC and AD, so the opposite sides. A quadrilateral whose diagonals bisect each other is a parallelogram. This is one of the properties that we learned from the previous videos. Given that in quadrilateral ABCD, OA is equal to OC and OB is equal to OD, I want you to prove that quadrilateral ABCD is a parallelogram. So how can we prove this? Well, in triangles AOB and COD, we know that OA is equal to OC, angles AOB and COD are congruent, and OB is equal to OD. Therefore, triangles AOB and COD are congruent, according to side angle side. Therefore, angle BAO is equal to angle OCD, and angle ABO is equal to angle CDO. So AB is parallel to CD and AD is parallel to BC, which means that this quadrilateral is a parallelogram. Here is our conclusion. The third method of determining parallelograms is according to the notion that a quadrilateral with diagonals that bisect each other is a parallelogram. Geometrically explained, this would be if we're given a quadrilateral ABCD and AO is equal to CO and BO is equal to DO, quadrilateral ABCD would be a parallelogram. Let's do some practice. Can you identify which of the following quadrilaterals are parallelograms? Let's look at the first one. This first one would be a parallelogram since the diagonals bisect each other. Here, this would also be a parallelogram since same side interior angles are supplementary angles, meaning that they add up to 180 degrees and a pair of opposite sides are the same length. So if you have one pair of opposite sides that are both parallel and congruent, it means that that shape is a parallelogram. Here, this would also be a parallelogram, and here it would be a parallelogram as well. Given that on quadrilateral ABCD, E and F are 2 points of the diagonal AC, and OE is equal to OF, prove that quadrilateral BFDE is a parallelogram. Well, here's our proof. Quadrilateral ABCD is a parallelogram, meaning that BO is equal to DO. Since EO is equal to FO, quadrilateral BFDE is a parallelogram. So here's our first example. And our 2 points on diagonal AC of ABCD, and AE is equal to CF. Prove that quadrilateral BFDE is a parallelogram. Well, we can first start by connecting BD, which is the diagonal of quadrilateral ABCD. and it intersects with AC at point O. In ABCD, AO is equal to CO and BO is equal to DO. Since AE is equal to CF, therefore AO minus AE is equal to CO minus CF, which means that EO is equal to FO. And because BO is equal to DO, quadrilateral EFDE would be a parallelogram. A quadrilateral whose diagonals bisect each other is a parallelogram. Here is our second example. Fill in the blanks according to the diagram. Pause the video and fill in the blanks. So here you're being asked to give another strip of information in order to prove that quadrilateral ABCD is a parallelogram. What else do you need in order to make this a parallelogram? If we're already given that AB is parallel to CD, we still need to know that AD is parallel to BC. If AB is equal to CD, and if we also had AD is equal to BC, then this would be a parallelogram. If OD equals 5 for the third one, then this would also be a parallelogram. And here's our fourth one. As shown, diagonals AC and BD of parallelogram ABCD intersect at O. E and F are 2 points on AC. If blank, quadrilateral BFDE would be a parallelogram. If AE equals CF, then this would be a parallelogram. So since ABCD is a parallelogram, AO is equal to CO and BO is equal to DO. Because AE is equal to CF, then AO minus AE is equal to CO minus DF, and EO is equal to OF. So BFDE would be a parallelogram. But is there any other proving method? Well, think. What angles can be considered to determine whether a quadrilateral has a pair of parallel sides? So here is a graph. Under the entire category determining parallelograms, there's 3 ways we can do it. We can consider it from a side. So a quadrilateral whose 2 sets of opposite sides are parallel is a parallelogram. That's by definition. But another way we can prove that a quadrilateral is a parallelogram by looking at a side is that a quadrilateral whose 2 sets of opposite sides are equal is a parallelogram. That's our first method. And our second method is a quadrilateral whose opposite sides are parallel and equal is a parallelogram. If we were going to consider this from a side, then a quadrilateral whose opposite angles are equal is a parallelogram. And finally, if we look at an angle, a quadrilateral whose diagonals bisect each other is a parallelogram, and this is our third method that we just looked at. So let's do a quick exercise. When Karen made a jigsaw puzzle with 6 congruent regular triangles, they formed a hexagon. Can you find all the parallelograms in the picture? Now pause the video and try to do this on your own. So there are 6 parallelograms. As you can see, it would be this right here, and then ABCO, basically any combination of 2 adjacent triangles. Class summary. So here we just have the diagram from earlier, which is all of the possible ways of determining parallelograms. This is a really good time to pause the video and just summarize all of the methods we have so far of determining parallelograms. Lesson summary. Today we determined parallelograms using the property diagonals bisect each other, and we applied this theorem to solve problems. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.